So in part B, same directions, we want to find the inverse if it's a one-to-one function in the first place. G of x equals 2x cubed minus 5. So how do you verify that it's one-to-one? Probably best to just graph it and then use the horizontal line test. So more review for the final. Do you know how to graph a function like this? It's actually a third-degree polynomial function, isn't it? I haven't given you any particular methods for that, right? So what do you fall back on? Just plotting points, right? So what you could do is just make a table. X, in this case, the output's g of x. It's a relatively simple, they call it a cubic function when it's degree 3. It's a relatively simple cubic function. 2x cubed minus 5. What kind of x values would work to plug in maybe? 0, maybe 1 and 2, and then how about -1 and -2? Okay, if we plug in -2 for x, so we're essentially taking g of -2. We get 2 times -2 cubed minus 5. What does that turn out to be? Well, what's -2 cubed? You got to do that first. -8 times 2? Negative, right? And then, what, -21? Ooh, that's kind of far down. I don't know if I want to plot that point. So I probably won't. I won't plot that point. What happens if we plug in a -1? G of -1? 2 times -1 cubed minus 5. What does that turn out to be? Yeah, so that'll be a -2 when the smoke settles in front, minus 5. -7. I can plot that point. -1, -7. What about 0? That's easy. What do you get when you plug in 0? Oh, I don't know. What is this point, 0, -5? It's the y-intercept. Anytime you plug in 0 for x, you're finding the y-intercept, whether it's a cubic function, a quadratic function, or a linear function, or any other kind of function. Doesn't matter, with 2 variables. Okay, g of 1, what do you get for g of 1? G of 1, we get 2 times 1 cubed minus 5, -3. G of 2. Oh, that's going to be what? Yeah, 2 times 2 cubed, which is 8, 16 minus 5. 11 maybe? That'll be enough points. Plot it. So I'm going to do 0, -5 first. 0, 1, 2, 3, 4, -5. Okay. And then 1, -3, so over 1 down, 1, 2, 3. And then what else? 2, 11, I don't know. I could kind of get it on there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, somewhere up here, right? And then -2, -21 is too far down. I'm not going to worry about it. But -1, -7 would be right here. And so, okay, it's going to be hard to graph that point. So I'll kind of just head in that direction. I won't get all the way up there. And it's not going to be a straight line. It has a little bit of a curve to it. But I mean, I think you can kind of tell what it's going to look like. It's going to head way down there. It's going to head way up there. What do you think? Is this thing going to pass the horizontal line test? Draw a couple horizontal lines and say 1 to 1 by HLT. So I spent time on that because I do like to review where I can. I don't have time to review much, but in the context of other problems, it's good to see that review. That's just one part of a much bigger problem, isn't it? By the way, if you have a graphing calculator, you could verify that pretty darn easily, couldn't you? Okay. So actually finding the inverse is probably easier than that would be, I guess, step 1. We called it earlier. Step 2, find the inverse. What did we do next in the last problem? Replace, in this case, g of x with y. So y equals 2x cubed minus 5. And then what do we do? Step 3, To create the inverse, we switch x and y, don't we? So x equals 2y cubed minus 5. And then what do we do in step 4? I'm going to rewrite it as 2y cubed minus 5 on the left equals x, because what do I want to do? I want to solve for y. Okay, okay, to solve for y, don't let the y cubed scare you, just isolate it. There's no other power of y. So this is like solving by taking roots, except it's not a squared power, it's a third power. So isolate the y cubed. What do? Add 5 to both sides. You get 2y cubed equals what? X plus 5. Adding 5 to both sides. Notice I'm not showing all the steps anymore. It gets too messy if you show the little plus 5. I mean, if you want to do that, that's fine. But I think it looks a lot cleaner if you just show what you do instead of that intermediate step of adding 5 vertically. And then what do? You could either think of it as division by 2 or multiplication by 1/2. I don't really care. If you want, you could just take the whole thing and divide by 2, that whole right side. That's the same as, by the way, as 1/2 x plus 5/2, because the division by 2 distributes over addition just like multiplication does. And then finally, if we have y cubed and we want y, not y cubed, what could we do to both sides? We could take the cubed or third root, the cube root or third root. And that gives us on the left side y, on the right side, it's a big cubed root of x plus 5 over 2. We're not going to worry about rationalizing that. We'll just leave it as is. But what was the final step I asked you to do? Replace what with what? Yeah, in the last problem it was called f, and we replaced, the original function was called f, and we replaced y with f inverse at the end. Here, the original function is g, so we're going to replace y with g inverse. So g inverse of x, replace y with g inverse of x. Get g inverse of x is equal to the cubed root of x plus 5 over 3. Is it 2? Yeah, sorry. There we go, 2. All right.